In this video, we're going to have a look at normal distributions. And a normally distributed set of data looks like the graph we have here, where it sort of looks like a bell curve, which is another way that we can use to describe it. So the frequency, the most frequently occurring piece of data is in the middle, which means that it is both the mean and the median of the data. So it's right in the middle. It's the most frequently occurring piece of data, but it's also the average as well. One of the things we know about a normally distributed set of data is that 68% of that data lies within one standard deviation of the mean. So remember that X bar is the mean. 95% of the data lies within two standard deviations, so +2 and -2. And finally, 99.7% of data lies within three standard deviations, so plus and minus 3 standard deviations. If we put all of this information together, we have this graph. So we can see that here is the mean in the middle, and +1 standard deviation, -1 standard deviation. Within that, 68% of that data lies there. 34% on this side, 34% on that side. Two standard deviations, we have 95%, and then three standard deviations, we have 99.7% of the data. Outside of that, we have 0.15% on both sides. This graph, this diagram, really important to have on your cheat sheet for both your tests and your exam. How do we apply this data though? That's the next step. So if we look at this example, a company sells radios with a mean life of 18 months and a standard deviation of 3 months. The company will replace the radio if it is faulty within 12 months. Okay, so we know that the mean is 18 and a standard deviation of 3 months. So here we're going to have 21, 24, and going backwards, 15, 12, and 9. It'll replace it if it's faulty within 12 months. So when we're looking at time, from the time it's first made through to 12 months, they can replace anything that breaks down here. To calculate that number, it's 2.35%, which is this area, and the 0.15%, which is this area. So they will replace 2.5% of radios. If they sell 5,000 radios, how many will that be? Well, 0.025, 2.5% as a percentage, multiplied by the number of radios, and that will give us how many radios they will actually replace. So this is an example where we're using the standard deviation curve to read off our numbers. So our normal distribution curve using our standard deviations just to find out an actual number. They're not always going to be this simple, especially if they are something like 16 months. And that's where we need to use our calculator. Again, another example, mean of 95, 95 in the middle, standard deviation of 8, 103, 111, 119. So between 87 and 103, what percentage lies between here and here? Well, we know that that is 68%. 103 and 111, well, that's from here to here, 13.5%. This is why this diagram is really important for you to include. To use your calculator to do these, we're again using the statistics function in your calculator. And then we're going to distribution, and we're looking at the normal distribution. So we're going to flick over to the screen and do the example. But remember, we've got the two symbols here. So mu is the mean. So I think looks like a U. It's Greek for mu, M for mean. Easy way to try and remember it. And the other one is your standard deviation. All right, so the length of King George Whiting Court in SA is normally distributed with a mean of 38 and a standard deviation of 3.5. What percentage of Whiting would expect to be in that length? So here, using my calculator on the right-hand side, I'm going to use F5 for distribution, F1 for normal distribution, and in this instance we're using MCD. And we're going to look at the inverse a bit later. All right, so my mean was 38 and my standard deviation was 3.5. This is where I set my limits. So more than 40 centimeters. So if I've got my number line, 40 centimeters, more than 40, 40 is going to be my lower limit. And my upper limit, well, I don't know what my upper limit is. It could be the biggest fish possible. To work that out, I'm just going to put in E99. So what that's telling me is it's an extremely large number. If I scroll down to execute, my p-value, probability, is 0.28. So my probability is 28% that I'll catch a fish more than 40 centimeters. Conversely, if I do less than 33 centimeters, it's going to be that way. So my upper limit is going to be 33, and my lower limit, well, it's got to be the smallest number possible. It can't be 0 because that wouldn't be a fish. So I have to use the negative button, negative E99. So that means the smallest number possible, closest to 0, but it's not 0. Again, I scroll down and calculate. My p-value is 0.08. So about an 8% chance of catching a fish less than 33 centimeters. Between 35 and 45, well, my lower limit is 35, my upper limit is 45, standard deviation and mean are the same. Calculates, I've got a 78.2% chance of catching a fish between 35 and 45 centimeters. What we've been doing here is finding percentages, but when you get an example like this one, it's slightly different. So a machine fills bags with icing sugar. The mean net weight is 2 kilograms and the standard deviation is 0.1. If 5% of the bags are rejected for being too heavy and 10% of the bags are being rejected for being too light, in what range must the weight of a bag lie to be acceptable, assuming the weight is normally distributed? So what I'm going to do, I'm going to exit out of this function. I'm going back into distribution, normal distribution, but this time I'm going to use inverse. So I'm going to use F3. So here we're finding a number. NCD will give us a percentage, but with inverse, that's where we have a percentage and we want to find a number. And in this instance, we have a percentage and we want to find a number. So our options are slightly different on this screen. You can see that we have a tail from the left. So what that means is when we start from 0, how far in would you like to come? So 10% of the bags are being rejected for being too light. So if I start from the left and come in 10%, that's going to give me a value. So what area would I like? I'd like 10% as a decimal, which is 0.1. My standard deviation is 0.1. And my mean is 2. If I scroll down and execute, it will be 1.87. That's in kilograms. So if it's less than 1.87 kilograms, it will be rejected for being too light. 5% are rejected for being too heavy. So if I come up to my 95th percent, anything above that, up to 100%, is too heavy. So I exit out on my calculator, and my area is going to be from 0.95, the 95th percentile. I scroll down and execute. So if it's greater than 2.16 kilos, it will be too heavy. So if any bags weigh between this range here, 1.87, 2.16, they will be acceptable. And again, another example, student hoping to pass an examination is told the mean mark of the class was 63 with a standard deviation of 20%. So 17. 20% of the class failed. What is the minimum mark he must have achieved, assuming the scores are normally distributed? So again, from the left, 20% failed. So that's low scores. So 20%. So 0.2. Oops, sorry, that's the area, 0.2. The standard deviation was 17. And the mean was 63. What mark must you achieve? Score of 48.7. Or 49 he must achieve to pass.